all matter can be divided into two different categories. Matter is either a pure substance or it is a mixture. Now, a pure substance is either an element or a compound. I'll talk a little bit more about mixtures in a while. So an element is a substance that cannot be broken down into any simpler substances. It contains only one type of atom. So we've got gold or copper or aluminum. So how do we determine whether or not something is an element or a compound? In order to know if something is an element, we just look on the periodic table. The periodic table lists all the elements that exist on the planet or have existed on the planet. So if it's not on the periodic table, then it's not an element. Each element is given a specific name and it has a symbol. So the symbol is either one or two letters. If it's two letters, the first letter is capitalized and the second letter is lowercase, which is really important. So you can see here like Li is lithium, Mn is manganese, Al is aluminum. And you're going to begin to start learning some common, not all of the elements on the periodic table, but a portion of them that are commonly used in this class and in the lab. So you're going to begin to memorize the names to the symbols or the symbols to the names. Now, a compound is when you have more than one element joined together, but it's specifically joined together in a fixed proportions or fixed ratio of elements. And the only way that we can separate the parts of a compound is by undergoing a chemical reaction. So, for example, water is a compound, and the chemical formula for water is H2O. Now, what this means is you have hydrogens and you have oxygens, and it's a fixed ratio of hydrogen to oxygen. So there's always 2 hydrogen for every 1 oxygen. Okay, so 2 hydrogen per 1 oxygen. If there is a different ratio of elements, then you have a different compound. Now I'm just going to talk a little bit about an atom here, which will come into play in the next unit when we learn about the structure of atoms and elements. So an atom is the smallest particle of an element, and each element has atoms that have a unique structure. And they're made up of what we call subatomic particles, which are protons, neutrons, and electrons. And in the next unit, we're going to learn all about the proportions of the protons, the neutrons, and electrons, and how that affects, what element we have. Okay, so let's talk a little bit about mixtures then. So remember that we have the 2 separations. We have pure substances, which are elements or compounds. Otherwise, all other matter is a mixture. So a mixture is something that can have a composition that is varied. It's not fixed. As opposed to compounds, remember, they always have a fixed proportion of things, and elements are always made up of one specific type of atom. So a mixture can have a non-uniform composition. So we then divide mixtures into 2 different types. There are heterogeneous mixtures. So hetero means different, right? So a heterogeneous mixture is one that you can see the parts and they're noticeably different from one another. So if you look at trail mix, you can distinguish the parts visually. You can see that there's raisins and nuts and dried fruit and so on. A homogeneous mixture is one that you cannot distinguish the parts. So homo means the same. So a homogeneous mixture is a mixture that looks the same throughout. All right, so then we can divide those into, other hats as well. We can subdivide them even further. So all homogeneous mixtures are called solutions. So solutions look the same throughout. Heterogeneous mixtures can be either suspensions or something called colloids. And whether or not a substance is, or a mixture is, a solution, a suspension, or a colloid is defined by the particle size. What are the particles that make up the different mixtures? So I'm going to go further and define all of those. So a solution is very important that we understand that it's a homogeneous mixture. So solutions do not separate into any sort of layers and they look the same throughout. Parts cannot be filtered out. So, if I dissolve salt in water, I've made like a salt water solution. And if I were to pour that through a filter, I couldn't get the salt back out. So there's ways in which we can separate a solution, but we can't do it by filtering because the particles are too small. Now, we can see through a solution, so light is not scattered. And we can have different kinds of solutions. We can have a solid, a liquid, or a gas. The liquid is the most common that we think about as solutions. So here we've got, some solution there. Who knows what that is? It might be some copper chloride or something. And, Kool-Aid is a solution. You put your juice pack in, you put your sugar in, and it all dissolves in the liquid. So that's a liquid solution. This right here is an example of a solid solution. So this is bronze, and bronze is an alloy, which is a mixture of two metals. It's when we melt metals together, and bronze is actually a mixture of copper and tin. And typically alloys have properties that are more favorable. They're stronger, and that's why during the Bronze Age, bronze was a very strong metal. Most metals are very soft when they're in their pure form, and it's beneficial to have a strong metal for practical uses. And then also we have like gaseous solutions. So if you just think about air, we know that air is made up of all different kinds of gases: nitrogen, oxygen, carbon dioxide. So that's an example of a gaseous solution. Now, a suspension can separate into layers, and the layers of a suspension we call phases. So if you look here, we've got like a mixture of some water and some oil, okay? And we can definitely distinguish the layers. If we let it sit long enough, it would settle out, and each of these layers is called a phase. In a suspension, the particles are suspended and they're large. We can actually filter them out. And light is typically scattered. They typically can look cloudy when they're suspended. Also, something to think about in terms of the lab that we're going to do, anything that needs to be shaken before used is a suspension, because what that means is that it has separated into its layers, and to have its full effect, you would need to shake it. So like medicines and things like that need to be shaken are suspensions. Okay, and then lastly we have a colloid. Colloids are heterogeneous mixtures, but they don't separate into layers. And sometimes this confuses people because it kind of looks the same throughout. When you look at this, it looks the same. It looks like all brown. It's not going to separate into visual layers. So what is the difference between it and a solution? Well, it contains medium-sized particles that are suspended, and it scatters light. So even though it looks the same throughout, the fact that we can't see light coming through it is what makes it a colloid. By looking at it and seeing it like this color, we're actually seeing the particles because it's bouncing off and reflecting into our eye. Okay, so hopefully at this point you understand a little bit more about how to categorize and classify matter, and we'll actually be doing several labs in which you'll be able to look at household items and determine what type of matter they are.